All right, in this video, we're going to solve a problem with acceleration in free fall, basically something that is only being affected by Earth's gravity and nothing else. So let's start by looking at this question. A rock is dropped off a cliff. So anytime something is dropped, it is not starting with any speed. We would say its initial speed, VI, is 0 because you're not throwing it, you're just releasing it. So I'm going to fill in here, VI is 0 meters per second. That's the starting speed. Now, gravity is going to cause this rock to accelerate downward. And because it's only falling, I'm going to say acceleration is positive 10. Now, you could, if you wanted to go it down being negative, call it negative 10, but I prefer positive numbers. And so if this thing's never traveling upward, I'm just going to use the convention that down is going to be positive 10. So that's the acceleration. And then it says 4 seconds later. So this is the information I can get from the initial problem. So these are all the variables that might come up in the problem. And so our goal is to try to fill these in as best we can. So how fast is it going 4 seconds later? So VI, the initial velocity, is 0. Now we're just trying to figure out how fast it's going later. Basically, it's asking us for VF. So we can use this equation here to find VF. And so VF is going to equal VI, which is 0, plus A, which we're calling 10, times T, which is 4. If we do that out, we get 40. So this rock starts at 0, and 4 seconds later, it is going 40 meters per second downward, which again, the way these work is every second that an object is falling on Earth, its velocity changes by 10 meters per second. In this case, it's getting faster and faster. So it's going 0, then 10, then 20, and by the end of 4 seconds, it's going 40. So now I'm trying to find how far it falls. So how far it falls is delta x, the change in position. I have two ways of doing this. I can use this equation to find delta x, or I can use this equation to find delta x. I'm going to do it both ways just so you can see the approach. So if I want to use this first method, I first have to find the average velocity. So average velocity is just what it sounds like. What is the, average, what is the middle velocity in some ways? So if I'm starting at 0 and ending at 40, what is the average of those two? It would be 20. 0 plus 40 divided by 2. 20 is right in the middle. So that's the average velocity, and I know the time, so I would just take this equation. I'd say 20 meters per second equals delta x over time, which is 4 seconds. And so what is the change in position? If I multiply each side or cross-multiply or multiply by 4, I'll get delta x equals 80 meters. So if you average 20 meters per second for 4 seconds, you will travel 80 meters. And that is one way to find delta x. The other way is just to use this equation. Delta x equals VI times delta t. Well, VI is 0, so t is 4, plus 1/2 A, 10, times t, 4, squared. So this is 0. So you get 0 plus 4 squared is 16, times 10 is 160, times 1/2 is 80. So you also get 80. It doesn't really matter what method you use. So that is sort of how we solve one of these motion problems. Also, if I want to finish, what is the change in velocity? Change in velocity is VF minus VI. So that's just going to be 40 minus 0, which is 40 meters per second. So it changes by 40. And that's really all I get from that. So anyway, that is how I go about this. And then if I were reporting this on a question, how fast is it going 4 seconds later? I would actually want to write out, it is moving, I want to write out the answer because the chart itself is not an answer, it's a tool. So I would say it is moving 40 meters per second and it has fallen 80 meters. So I would want to somehow translate that into an answer. So the chart, I will give you this chart for now to use whenever we do these problems, but eventually you're going to want to try to fill out your own chart. So again, there's 4 velocities: initial, final, the change, and the average. And then there's just time, acceleration, and position. TAX, you can think tax. Those are the other 3. And so it's just a matter of filling what you can and making use of these equations to solve for what's missing. So another video, I'll do another problem. We can try that out. I suggest pausing it and trying it on your own first. But that's it. Until next time, I am Derek Genova. Have a delightful day.